Hey there. Ever wonder how AI systems like chatbots or coding assistants get better at understanding you? It's not just about feeding them more data, it's about teaching them what matters. Today, we're diving into a groundbreaking study that reveals how AI is learning to think more like humans, using something called reward models. Let's break it down. So here's the thing, AI doesn't just know answers. It learns what good answers look like. And that's where reinforcement learning from human feedback, RLHF, comes in. Think of it like a teacher giving feedback on a student's work. Humans rate AI responses, and the model learns to prioritize answers that get higher scores. But here's the twist, not all teachers are created equal. Traditional reward models often rely on explicit comparisons, like asking people to rank responses. But what if we could teach AI to infer preferences more efficiently? That's where POLAR-7B shines. This method tackles a critical problem, aligning AI policies with human judgment without requiring endless human labels. Let's unpack how it works. POLAR starts with unsupervised pre-training, a process that's like teaching a student to recognize patterns without direct instruction. Imagine a teacher showing examples of good and bad performances, letting the student intuit what makes one better than the other. POLAR does something similar. It trains a reward model to distinguish between policies by comparing their outputs. Instead of relying on human labels, it uses a mathematical trick, measuring how different policies generate trajectories, sequences of actions or responses. This creates a criterion-agnostic reward model, meaning it doesn't assume specific human values up front. Think of it like learning to judge a painting without knowing the artist's intent. You look at patterns, style, and consistency to guess what might be better. POLAR's pre-training phase is this early stage of intuitive understanding. It's not about memorizing rules, it's about grasping the essence of quality. But here's the magic, POLAR doesn't stop there. After pre-training, it moves to supervised fine-tuning, where human input refines the model. Here's how it works. Researchers generate multiple responses from the same AI policy, then ask humans to rank them from best to worst. Even though all responses come from the same policy, the rankings encode subtle human preferences. The reward model then learns to mimic these rankings, bridging the gap between machine logic and human values. Picture this, a chatbot generates 3 answers to a question. A human says, this one is best, this one is okay, and this one is worst. The model uses these rankings to adjust its reward signals, nudging the AI toward responses that feel more natural or helpful. It's not just about matching a reference answer, it's about evaluating accuracy, relevance, and style in real time. What makes POLAR powerful is its two-step approach. The pre-training phase gives the model a broad understanding of policy differences, while fine-tuning adds the specific, human touch. This combination allows the reward model to generalize better and adapt to diverse tasks without requiring endless human labels. Let's talk numbers. In tests across 18 benchmarks, ranging from coding to math to common sense reasoning, POLAR-7B outperformed other models. On tasks like AlpacaEval, it hit 68.7% accuracy, beating competitors by over 10%. In MT Bench, it scored 8.43, a clear jump from the baseline. Even in tricky areas like HellaSwag, common sense reasoning, POLAR-7B nailed 88.87% of answers. But here's the real kicker, this isn't just about raw performance. It's about how the model learns. Researchers trained it on 3.6 trillion tokens, enough text to fill a library of 10,000 books, and optimized its training with scaling laws. These aren't just rules of thumb, they're mathematical guides that show how to balance model size, data, and computation for the best results. And let's not forget the human touch. By using diverse models to generate responses and carefully filtering out biases, POLAR ensures its reward signals reflect a broad spectrum of human preferences. This isn't just about accuracy, it's about building systems that feel intuitive and trustworthy. Why does this matter? These models power the AI tools you use daily. Whether you're asking for a math solution, a coding fix, or even a creative writing prompt, the better the reward model, the smarter the AI. It's not just about getting the right answer, it's about understanding why the answer matters. So what's next? As these models grow, they'll tackle even trickier tasks. But the real question is, how will you use them? Stay curious, and let's keep exploring the future of AI together.